went too close.
Oh, it's a dog. That's awesome. Man versus machine. Look at that. He is tiny.
Hold on, watch this.
Oh, do the crouching. Oh, battle mode. How about the crouch? The crouch stance. Oh. Oh, yes.
If I can think of myself right now, I can definitely be.
Oh, yeah. Well, I'll give it to you for sure.
So you get a giant robot, you bring a giant robot into your office, and obviously the first thing you want to do is introduce it to your dog.
Well, it's my dog, so
It's your dog, it's your robot, naturally.
he has been exposed to robots before, and that's probably one of the reasons he had that reaction. And I think it was actually, this was filmed in the playground parking lot, and I think it was Tim Draper was over to visit, and he was actually the cameraman on that one with the feisty terrier trying to herd the robot dog.
So that's Playground Global. That's what you're up to now. I wanted to just sort of take it back a second and discuss your previous robotics ventures. Obviously, the first time you got involved with the Spot Mini and Boston Dynamics is when you were still at Google. Acquired a whole number of robotics companies. Was Google just not the right home for 15 robotics companies?
Well, it was definitely the right home to acquire 11. I think it was 9 of them public, but the total was 11. So obviously what we're trying to do is accelerate the effort, and doing acquisitions is a great way to do that. Once you acquire 11 companies of any kind, robotic companies or any other kind, the herding those things all into kind of a common strategy, a common goal, getting all the companies that used to have CEOs, running them to agree on a product roadmap and things like that are pretty hard. It took about a year to get that straight, and then it was, I think, well established, and I could move on to my next thing.
What was the common strategy at the time? I mean, we're talking about, again, Boston Dynamics. We're talking about a number of these pick-and-place robots. From the outside, at least, it looked like it was kind of all over the place.
I appreciate that.
Listen, you're a genius, and I'm sure you knew what you were doing.
It's threading the needle a little bit, but so I don't want to give away any proprietary
Sure.
information. There's a bunch of confidential stuff.
Nobody's listening, Andy. It's fine. Just whisper it in my ear.
A lot of that stuff is actually still going on, so I think it's. I'm pretty pleased with what I hear. But in general, I think with automation, a lot of the opportunity with automation, whether it's a self-driving car or robot or an industrial robot in a factory, it really starts making a lot of these problems in logistics and routing and decision making. It's obviously becomes a software problem once you have the actuation. If you think about the life of an employee who works in an Amazon warehouse, right? What they do is they're sitting there and they wait for their cell phone to vibrate, right? And they look at the screen and it says, go to this rack, this level, this bin, and pick the package and bring it to station 5.
Yeah.
Right? So the human goes and does that and then completes the task and waits for his cell phone to vibrate again.
They've got a countdown going. The machine knows exactly how long it takes to get to point A.
And they know how many steps
Yeah.
it takes and everything else. So it's an efficiency problem, and the human's in the loop, and the human's probably the most inefficient thing, right? So, of course, Amazon's done a great job at automation. They continue to do so. There's a lot of companies chasing that. But to be the person in that loop, you're the fault. If there's a MTBF and there's a fault tolerance, you're that. The spotlight's on you. And it's already been defined as a software problem because from an order all the way through to that person's cell phone ringing, right, is software, right? So, some algorithm picked that person because they had knowledge of that area of the warehouse and they're in the right zone to go and do that task.
So is it going to be necessary, in order to really advance robotics to a point where they become truly ubiquitous, to have a large company like you mentioned Amazon or Google at the helm?
Well, I think, initially a lot of this stuff, we've had, I think, 1961, the Unimotion Unimate was one of the first industrial robots, right? So we've gone through these various kind of cycles of innovation. And now we're in a cycle where there's some disruptive technologies, machine learning and artificial intelligence, have been applied to these things. And in my view, it just so happens these large companies, or the mega corporations, they're the ones that are leading the AI charge. It's a data business. A lot of data needs to be accumulated and processed, and these companies already have infrastructure to do that. The number of compute power, the amount of CPUs and the amount of compute power in a data center at an Amazon with AWS, or a Google whose job it is to satisfy search requests. There's a lot of compute there that has been slowly repurposed to machine learning and artificial intelligence.
So, as somebody who is back in the robotics funding game once again, what are some of the lessons you learned from that first time out when it comes to choosing a successful robotics startup?
Well, so part of Playground's thesis is we're a $900 million venture fund. It's pretty diverse. We'll invest in early stage, later stage, and we'll invest in some pretty long shot, crazy stuff, and then we'll also invest in nearer term stuff. And obviously, from a finance world, that's just arbitrage. You want to make sure you're kind of covering all the sectors with your capital. The learnings that I had kind of coming into Playground for this style of investment is this isn't going to happen overnight, right? These are long-term bets you have to take. And, kind of piece by piece, it's like, building a puzzle. Rather than doing the thing that's the 10 or 20 year out thing, there are waypoints to get to that milestone. And you have to invest relatively strategically to kind of fill in those puzzle pieces for the waypoints, but each one of those waypoints can be a successful standalone entity, a company. And that's what I think venture does best.
So is it looking towards short and long term with each of these companies specifically? I mean, again, we had Mark Rayburn on stage earlier, and they mentioned that, for the first time in their 25-year history, they're starting to really look short term as well. They're going to be commercializing this robot, and obviously that's what affords them the ability to do these moonshots at the same time. As you're looking at, there are about a dozen robotics companies in your portfolio?
Yeah, I think I don't keep track of all of them. Some of them are confidential, but it's about 11 or 12 right now.
So do you look at companies that both have short and long-term potential?
Well, look, 25 years ago when Boston Dynamics was founded out of MIT or wherever, if you were to tell them 25 years ago, in 2 years I want you to come up with a commercial anything, they wouldn't have been able to do it. So what's happening today is founded on the platform of 25 years of innovation, right? So some of the investments we're going to do are investments around innovation where we think the industry will end up, right? So it's a little bit wargaming out where you think things will end up. For example, we have investments in quantum computing, right? Now, it's not feasible at the scale that they've decided to tackle to do that today. But if you believe in physics, you can understand that someday there will be quantum computers, right? So everything else can kind of fall in line with that and obviously supercharge machine learning and artificial intelligence and everything that comes along with it.
So we can't just create a wormhole and have that be profitable overnight?
Maybe not going to happen overnight, and certainly you'd want to protect yourself from getting sucked into that wormhole.
You seem to be well positioned, though, where you are now to really sort of, invest in these moonshots. Is it important, though, that these companies do become profitable quickly in order for them to remain in your portfolio?
Of course. For me, this is graduating from a company like Google that had the resources to think really long term into a role as a venture capitalist. My job is to make returns on the fund, right? And I want them to be 10x returns, which is crazy, by the way. So obviously, we need to be making sound, wise, good investments that have a return for our limited partners.
So you talked about quantum computing, and we talked about these bipedal humanoid robots. Those are a bit further out. But what are, especially in your portfolio and broader, what do you see as being the most profitable short-term robotics investments?
Well, look, I think some of the technologies necessary to build self-driving cars, for example, are robotic technologies. Navigation, software navigation, and new ways to think about navigation software are important parts of that. I think regulatory-wise, self-driving cars are, a ways off. I think, we've all read the stories and we've all witnessed some of the learnings in that field. But applying that exact same technology, for example, in a warehouse, right? It's not regulated and it's a lot safer, and it's a relatively structured environment. So we have a company called Canvas Technology that has written a ground-up navigation stack, just like a navigation stack for a self-driving car that runs for vehicles in a warehouse, for example.
So you've got warehouse logistics, you've got a drone company, you've got a farming company, you've got Agility Robotics that make the incredibly cool Cassie robot that we'll be seeing later today. Is there a cohesive vision across all of these in the same way that you had when you were at Google?
Well, I think, so first of all, I'm a venture capitalist. I'm not a C corporation, so I do have to think of these as standalone investments. So the cohesive strategy is that we think automation and intelligence is a disruptive force. AI is eating software. Machine learning and data are driving these things. And if you think about the definition of a robot, sense, plan, and act, you realize that you're in a data business. And that data is probably going to come from the real world rather than from something that's generated in the cloud. And what do you know? Robotics and automation live in the real world. And that's what their job is to sense and act, where the planning is going to probably be driven by some neural network in the cloud. So, that architecture, that technical architecture is something that is obvious to us. And our investments kind of plug into one of those pieces in that technical architecture.
I keep hearing about how everything's accelerating, how we're going to get to a point where robotics are going to be more ubiquitous than the smartphone. But one of the closest piece of technologies, as you said, is a self-driving car. And because of a lot of what's happening, because of these stories that are in the news, it still feels a ways out. I mean, how long are you actually projecting when you talk about this world where robots are truly ubiquitous?
Well, if you look at what people are doing with drones today, there's business opportunities. Skydio is one of the companies that I think is here. There's opportunity to apply the same technologies, the navigation, the obstacle avoidance, the following, and things like that, to consumer products today. If you think about machine learning and data and how to apply that into a consumer's life, I think it might be a little early, but look at even like a Roomba, your robot vacuum cleaner. Each one of those internally has a map of your house. So how many people in the audience have a Roomba? Right, so
this might not be representative of the public.
I only saw a couple of hands. Maybe people don't want to admit that now you've given away a map to your house. But I think some of these ideas have kind of been germinated in consumer products and will have a bigger role in this disruptive force when the data for these things gets federated in a way where they can serve a better good.
I keep hearing talk about robotics as a platform. One of the things that Android did remarkably well was create a cohesive platform across devices, create a framework, create consistency among any number of third-party products. Do we need a model like that for robotics to continue to be successful?
Well, look, I do look at these kind of waves of innovation that become platforms. I think software platforms and operating system platforms and things that power third-party developers creates a virtuous cycle. These things then in turn obviously create ecosystems that can be monetized in a variety of ways. The business model of platformization is something that is near and dear to my heart. For robotics and automation, the likelihood of there being one cohesive platform that everybody ends up adopting, I'm not sure. But if a lot of these companies can start agreeing on data sharing formats for machine learning, then the learnings of these things can be shared. And obviously, the transference of knowledge from one to the other happens instantaneously at the speed of light. And in general, I think that's a really, really good thing.
We had some folks from ROS on before. I mean, obviously that's as close as we've got to a ubiquitous robotics operating system. Is that the way of the future? Does it make sense to have that operating system across different devices?
I think, again, if you think about the architecture and how this is going to play out, it's going to be the large companies that own a part of the AI cloud, right? And these machines, whether it's your cell phone or whether it's a industrial robot in a factory or whether it's a consumer robot in your house, these machines are going to basically be the point of data creation, if you think of these as sensors. And that data is going to kind of flow up to the cloud and be processed in an intelligent way. That's the plan part of sense, plan, and act. And then they're going to come back down to these things and they're going to be actuated. The architecture of this is a lot different than like you and I are architected. You have your brain, I have my brain, I have my eyes, you have your eyes. We go and have our independent experiences and then we talk about them, right? And you and I talking about them into microphones to audiences is like the slowest, most painful way to communicate.
I'm enjoying it.
Our knowledge. I'm a little nervous. But if that could happen at the speed of light, where there's a million sensors sensing the world in real time, and they're all going to kind of a single brain in the cloud, and that knowledge can be transferred as many times as we like, well, shoot, that's like, teaching my 2-year-old not to spill milk, right? It took a long time, and then when I had to do that again with my second son, I had to go through that same experience of, teaching him not to spill milk. But in this architecture that I described, a robot learns not to spill milk once, and then no other robot ever does it again.
So what role is Playground Global able to play in creating that cohesive structure?
So I think, one of the things we think a lot about, so Playground is a typical venture capital firm mashed up with like an engineering firm. So we employ a lot of engineers, a lot of brilliant people, technologists that have invented some of the stuff that we're talking about today. And their job is to help the portfolio company, help the investments that we make, think about the impact of the stuff that they're creating, whether it's the social impact or a technical architecture, or even kind of pairing them up because they're solving adjacent problems where there's an underlying technology that might be useful for both of them. And I talked a little bit about federating data. How can these companies that we've invested in share data amongst themselves to accelerate their plan and give, obviously, Playground as a venture firm an advantage?
So here we have a special guest.
Yeah, we have a walking, talking guest. So one of the companies that we've invested in is a company called Agility Robotics. And I'm a big fan of biped robots. This technology leverages this notion of passive dynamics, which is going to become really, really important as we move forward here, because passive dynamics are similar to the way humans and biology and animals operate. My muscles in my leg don't look like a servo motor with a harmonic drive, which is what a lot of robots use these days. There's a different mechanical architecture to the way the human body and biology works. And this team has done a really, really good job of implementing that in hardware that's mimicking biology in a way where I think there's going to be a lot of, as a platform, there's going to be a lot of innovation built on top of it. And this is called Cassie, is the name of this robot.
So I have to ask you real quick, we don't have a lot of time left, but are you able to look at a robot like this and see commercial applications? Is this a robot that has a short-term payoff?
Well, remember, I do look at, so in order to do the things that this robot is doing in front of the audience here, there's obviously a lot of engineering and a lot of compute power and a lot of software and a lot of innovation that had to go to do this. And like I said before, I think in the terms of platforms, right? So why wouldn't I want to add legs to everything in the world? You've all seen here these, is it getting a little close to you?
He beeped. It was a mating call.
You've all seen these delivery vehicles, these kind of last mile delivery vehicles. If you want one of those to walk up the front steps in your house and leave a package at the door, the only way you're going to do that is with legs.
The world is built for beings with two legs.
For humans. And the majority of the population lives in high rises in these big urban areas, right? So you have to be able to ride an elevator to a front door. And that's just not something that we're capable of doing today with wheeled vehicles.
So next time you order something from Amazon, this guy might be,
Why not?
you might need to build some arms onto him, but
Yeah, why not?
you're halfway there. Great, Andy, thank you so much.
Okay, thank you.